Hello party people, welcome to the show. My name's Relevant and this is Do All the Things. And today, adventure, because I'm just gonna YOLO smash some transistors into my tube amp and see what happens. Some time ago, I discovered a new kind of amp that came out. Actually, it had been out a while now, I just hadn't been paying attention. And when I found out about these things, I was curious. Oh, what's the deal with them? Specifically, the JCM1. It is a 1 watt variant of the JCM800, and it gets 1 watts by taking a 12A U7 and using the 2 triode sections to make a little push-pull power amp of a very low wattage. As it has a push-pull configuration, it's gonna need a phase inverter. And when I was looking at this amp, I noticed it only has 3 tubes total, 2 preamp and 1 power amp. The JCM800 has 3 tubes plus the power tubes, 2 preamps, a phase inverter, and then the power tubes. One of the 3 tubes of the JCM1 is the power tube, leaving only 2 other tubes to do 3+0 gain stages plus a phase inverter. How do they do that? Scouring the internet, I found a schematic. I do believe this is an unsanctioned schematic, someone reverse engineered it, but we all look it over, oh, the quality's crap. We got 1 gain stage, normal, 2 gain stage, normal, 3 gain stage, normal, phase inverter. Okay, it's got a short tail phase inverter and then the push-pull. And then you're like, well, hold on. That's not a JCM800. JCM800 has 4 stages, 3 gain stages plus a cathode follower. Where's that cathode Wait, what's this? What? Is that a MOSFET? Marshall, you cheated. Yes, that's a MOSFET. They replaced the cathode follower with a MOSFET, an LND150. So naturally, I got curious and I looked this up. LND150, N-channel depletion mode DMOSFETs. DMOSFETs. It's not a MOSFET, it's a DMOSFET. Okay, let's look at the specifications. Oh, 500 volts. It's a high voltage MOSFET. It can handle what tube amps run at. Well, current capacity, 3 milliamps. 500 volts and 3 milliamps? What does that remind me of? A 12AX7. Except, well, a 12AX7 isn't technically rated up to 500 volts, but that's fine. 3 milliamps is roughly what they say the 1 triode section is going to consume when it's running in a tube amp circuit. So that means that this transistor can substitute a 12AX7 triode section. And indeed, if we look at the schematic, okay, cathode follower is just connected to the top power rail and it's got the 100K ohm resistor here. Oh, that's the coupling cap, that's normal. Other than this 4.7 meg resistor here tying past couple to ground and this 470p capacitor right there, which I don't know if that has anything to do with this. It is pretty much implemented exactly the same way that triode section would be in a real tube circuit. There is no provisions or changes whatsoever to really accommodate this MOSFET, which suggests to me it's just a drop-in tube replacement. I could just pop this into a tube socket, it's gonna work, right? Well, let's find out. Looking at this diagram is a map of the transistor itself. As you know, they are half moon shaped, much like that. Source, gate, drain. Okay, that's pretty simple. If we look at an actual diagram of it, drains the top, source is the bottom, gate is what controls it. It seems counterintuitive, but an N-channel MOSFET or transistor works that way because source, the current generally travels this way. They are negative switching. But you can see this is how it mirrors the tube diagram. So to implement these, I've found that you basically just, this is a map of your tube socket as if you were looking at it from the top, from the amp side. This is the gap. 1, 2, 3, we would just stick a transistor in like that, and 6, 7, 8, just simply, yeah, just jam it in there, bud. Just jam it in there, just like that. So let's give it a try. Enter this little buddy right here, Project Overdrive. This is an all-tube overdrive pedal that I made to drive my Marshall 800. Try to get rid of some of that solid-state technology. Ironically, we should be adding it back in. We have one 12AX7 and it's only using half the section. It effectively is trying to turn the Marshall into a 4+0 circuit. It was inspired by the Mega Drive 800 mod by Bruce Ignator in a 1995 March issue of Guitar Player magazine. I've talked talk to this much because it's kind of like my Bible that started me into tube modding. This is not in its final form, so like, be nice. But it still does sound pretty good. Just needs a little bit more modding. But either way, this is the simplest way to test this real quick because all it is one tube section, one transistor. And a good place to substitute a transistor for a tube is actually in your V1 position, your very first gain stage, because it doesn't have to distort. You're not depending on its clipping characteristics to generate your distortion texture. It just simply has to boost the signal to drive it into the amp. So let's see what difference it's gonna make. So let's give it a try without it first. Just the normal tube. Oh, I hit a wrong note there at the end, eh, bud? All right. All right. This guy works on pin 1, 2, and 3. So that would be right here. Ugh. Oh, there's still some residual power in there. Okay. It works. It just works. I just popped it in there and it's doing the job. Straight amp tone. Overdrive. Wow, ain't that something? Now the first thing I notice is that the tone is brighter and tighter. There's a little less squish. And how do I put it? It's just, there's more fuzz. The crunch is a little crunchier, but in a fuzzy way. You know, you hear this and you understand why tube might be superior to solid state. That is definitely a clear sound, but also more sterile and metallic sound. So, but it works for this. But what else is it gonna work for? Let's start swapping out some tubes and find out. I only have so many of these things, so let's put that back to a normal tube. Make sure it still works. Now the tube does have better mid bite, just better like, whereas the transistor is a bit flatter sounding. But then, you know, that's what's gonna happen with a transistor. It's gonna have lows that go lower, highs that go higher, and an overall flatter response. Whereas tubes, they add a lot of color to your sound, right? All right, here we have the Marshall up on the bench. And what's one of the first logical things we can swap out? Something that isn't necessarily dependent on distortion, especially the way I use my amp. And remember, I don't really go for the cranked amp tone. I want a clean, tight power stage. I don't like to distort my phase inverter. I don't like to distort my power section. The tone that I like falls apart when you do that. So I think the phase inverter is an excellent candidate for substitute. So let's give her. I got my little key right here, just so I don't screw up. This guy's labeled. All right, 1, 2, 3, 6, 7, 8. These are not very deep holes. Hardest part is getting it to make an electrical connection you trust. Okay, whatever. They look like they're in there. Let's see if the amp's still gonna work now. We have hiss. Oh. Oh, well, it works just perfectly fine. I can tell it's... Whoa, 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 whoa. Easy, chill, chill, chill. I can tell it's working because I know the difference between a half a phase inverter and a full phase inverter. That's definitely working. And again, it's brighter and tighter, but it doesn't screw with the tone as much because, you know, the amp's not cranked, that phase inverter's running clean. That just has to buffer and, you know, split the signal. In fact, it's actually quite interesting. The tone gets a little bit clearer. There's more clarity, but also, again, a little bit more metallic, a little bit more, yeah, it's just, I don't know how to describe it. Well, let's try a different tube position and see what happens. So let's put the tube phase inverter back into place. So let's kick it like Marshall's kind of doing in their JCM1 there, and let's change the cathode follower, but then consequently the stage in front of it too. Oh boy. This is loose. We need a better way to do this. You gotta kind of jam it into nooks beside the pins. Okay, they're in. I have no idea what tomfoolery to expect of this. Those are kind of partial distortion phases there. I'm gonna try without the overdrive first to see what happens. It sounds like an 800, but like more. It's weird. Now let's push her. Oh wow, that I don't even know how to describe what I'm hearing right now. Like it sounds almost identical to what the amp sounded like before, but just different. There's a little bit less note in the mid, like slightly more scooped, and again you can hear that kind of metallic fizz in there. So, okay, let's move on to this stage, because this stage with its cold clipper is going to have, the way I'm running the amp right now, a very profound effect on the distortion texture. Transistor cold clipper. Oh boy. All right, here we go. Again, I'm gonna start without the overdrive. Either something's gone wrong here. Oh, we got a bad connection. Okay, first thing I'm noticing is it has way more gain than the amp does stock with tubes. And in fact, it's interesting what I'm hearing because it kind of reminds me of the Jubilee with the little diode clipping, right? I feel like, does it have the same sensitivity? Okay, it's got a little bit less gain than the Jubilee, but it has that diode clipped tone to it now. Let's overdrive it. I immediately want to describe it as if you took the Marshall tone and carbonated it. It's the Club Soda JCM800. It's interesting because it actually has a nice tone without overdrive if you just want to add a little bit more buzz and to your tone, but it gets entirely too fizzy and fussy with the overdrive. On the other hand, it reminds me as if you added a fuzz pedal, like a fuzz pedal with a lot of gain. It's not a bad tone. It's not the 800 tone, but it's not a bad tone. I actually... say it, but I think it has a bit more sustain. All right, let's take this to the next level. I'm gonna replace 2 tubes with transistors now. Yes, sir. Yes, sirree. The entire preamp, all the distortion texture is going to be generated by these transistors. All right, all transistorized preamp. Okay, I got no overdrive on right now. Chugging just sounds gross. It's just so much, it sounds like what they call blocking distortion. But then strumming chords. It doesn't sound good, but it does sound interesting. Like the tube tone is definitely better, but it sounds like we could get into some really dirty blues territory here, you know? Sometimes the best blues tones just come from a really crappy sounding amp and you just play that thing and it's just, yeah. Okay, but we haven't overdriven it yet. We like. Okay, again, it has an interesting tone, but it's coming apart. It's just slop. So what I'm hearing happening here is because the frequency response of the transistors is wider, it's starting to add things to the tone that weren't there before, and the circuit is not set up for it. These things definitely, I can tell, have more low-end response. They actually sound pretty good in a phase inverter position because it'll get tighter and deeper sounding. However, the preamp circuit as it stands is not voiced to handle those low frequencies, so it starts to generate more blocking distortion. It starts farting out like what happens if you have too much low-end flowing through your gain structure. I would hazard to guess that if you wanted to voice a circuit specifically for these parts, you could probably compensate and clean up that sound and maybe get an interesting good distortion tone with them. But then, you know, we'd basically buy back to a solid state design and you might as well get a solid state amp. But one thing I am noticing is despite the flaws in the tone, it still sounds more dynamic than a typical solid state amp. Maybe once you filter out all those flaws, you'd end up with that flat, dead sound like you get from a solid state amp. So where do we go from here? I have 2 of these left. So for the first experiment, I'm gonna go ahead and replace the overdrive. So we're gonna have full transistorized distortion here. Just, we're going all in. Let's see what hilarity is gonna ensue now. First impressions, they actually sound better overdriven by one of their fellow teammates than they do by the tube. Like, this tone is workable. Again, it falls apart in the low end and the chunk and crunch, but The gain is out of control. I feel like I'm actually going to turn the gain knob down. Apparently I'm maxing out my mic. The amp has actually gotten louder. It's actually kind of very obnoxious and aggressive sounding too, but it does have this darkness to it. I could see the doom metal, sludge metal players really liking the sound of a transistor driven Marshall 800. That's probably like the thickest tone I've heard out of this amp in a while. It's dirty, it's sludgy, it's just like vomiting everywhere. Just but it's fun. Oh boy. I gotta put the tube back in the overdrive. I'm gonna replace the last tube in the Marshall with the transistors. Let's pull that phase inverter, bud. All right. They're all replaced with these transistors now. I think my patch cord's on its last legs. Okay, I don't know if that's... That did not sound good, and not because of the patch cord. It seems that having a phase inverter tube in place saved us from the harsh aggression that is generated by this preamp. And once I put that in the phase inverter, it was just too much. It was just like... You're like, no! So, yeah. Oh, that was interesting. So how do I feel about this? Well, I think I'm gonna be ordering a few more of these because I think they're gonna come in handy for when you want quick little cheats like that in certain tube circuits. I could think of a few situations in which I might want one of these where I have a tube amp design I'm doing or some sort of design, and I just, you know, I need a little boost somewhere, like a little buffer section just to kind of like bring that signal up a bit, but it's not important for that particular stage to be a tube circuit because it's just a little booster. I also find it extremely interesting, the sounds it generates. We can kind of, you know, get a fuzz tone out of this guy, or maybe a bit of a Jubilee diode clip tube tone out of this guy, but you know, not all at the same time. Very strategically, we replace one tube in the circuit and it can modify the tone in a pleasant way, a way that you might actually be like, yeah, you know what? That's the little secret that I'm looking for just to get my sound. In situations where you want natural full tube distortion, right? You want that distortion texture that can only be generated by tubes and tube clipping. Well, we're gonna put tubes in here, but if you want that distortion very accurately re-represented after the fact, then I actually find they might be excellent in the phase inverter position. Replacing that phase inverter tube with these transistors can enhance the tone. In fact, to be completely honest with you, I kind of knew what to expect because I tinkered with these things before filming the video. I didn't do all this with replacing all the preamp and stuff. This is the first time I've tried using it to see how the distortion texture we're gonna get out of a preamp is, but I did experiment with it in the overdrive, so I knew what to expect there, and I did experiment with it in phase inverters, and I kind of like it. For the phase inverter position, I kind of like it. I could see using these to replace certain supplementary tube stages, like reverb drivers, for instance, so that I don't have to waste a tube or pick the right tube just to drive the reverb in an amp when I'm barely going to hear those nuances of that tone to begin with. I could see using it in certain buffer positions. Like one way I've been using these things for the past since I got them is I replaced the effects loop tube in my Jet City with one of those. The Jet City has 3 preamp tubes, then it has a tube related to the effects loop recovery and buffer, and then it has the phase inverter tube. The effects loop recovery and buffer, if it's implemented the way I think it is, isn't going to add to your tone distortion wise at all, especially not in the Jet, which is designed to be a front end topology. It's not really designed to do the cranked amp tone. You just need a good clean sounding tube in that position, and there's nothing more cleaner sounding than a friggin' transistor, so I popped them in there and I liked it. It made that circuit more transparent and I didn't have to worry about what tube I could put in there. So do I recommend doing this? Yeah, actually, if you have the competence to be able to understand what's going on here on the schematic and understand that there is almost, 500 volts on there, and if you put these things in wrong, you could have like a little, basically kill them. They're only 69 cents each, Canadian. If you generally have the competence to rig this up, then yeah, I say give it a try. It's kind of fun and interesting, really. You might ultimately not like it in the end, but it's not the huge sacrifice in cost. In fact, I thoroughly intend in ordering some 12AX7 socket savers, much like that, permanently soldering a couple of those guys into the socket savers to have like a fully just substitute tube, and I could start playing around with it. Because yes, I can see myself seriously using these in phase inverter buffer positions to save myself the cost of a tube in an extraneous position. Especially, there's some older amps that I tinker with that, I don't want to put my good tubes in. Like my old custom reverb. I play my custom reverb. I want tube tone in the preamp, but I don't know if I care about tube tone in the reverb. In fact, let's try that. Let's put the Marshall away, and we're gonna take this experiment. We're gonna try something a bit different.